Okay, copy C 4-12 office hours. This is the pretest. So this is got a bunch of good practice in it. Just as a note, there will be probably about 4 graphing problems on the actual test instead of 7. So you might get some coordinate conversion problems which aren't on here. You're going to have a tangent line problem and probably slope problems. So probably like one of the problems from 8 and 9, probably one of the problems from 10 and 11. So probably 4 of these on the first page. And then probably one of these from 8 and 9, probably one of these, 10 and 11, probably one of these, 12 and 13, probably one area problem, and probably one length problem. And then also a free response style problem, like a full response style problem, which we might take that on a separate day, but like a 15-minute type of problem. I'll probably give you guys extra time. Anyway, so this is a little more than the test in some ways, but it's a bunch of good practice. So just graphing these, try and make these, I don't know, make them bigger, but probably good to label your axes. So r equals 2 is a circle, and it's centered at the origin. So usually you don't get those kinds. And then next one, let's see, r has to be between -1 and 1. So it's all the values of r in between those. And it's all the angles from 0 to pi over 4. So pi over 4 would be like that, right? And 0 would be like this. So it's going to be all those positive radius. I'm going to make this 1, 1, -1, -1. So it's going to be, you probably could go sketch a circle 1, rough, light dash line. And then it's going to be positive 1, so it's all of these, but it's going to be -1, so it's going to be backwards ones also. And so it's going to be everything in between. So it's going to be that. So there you go. Next one is a circle, but these are the more typical circles where they're kind of up or down with one edge on the origin. So I'd make a little table real quick. It should be a vertical looking circle because it has sine involved in it. But we can do a quick table. You get 0, 6, 0, -6, 0. You only really need 0 to pi for these kind of circles. So I guess we can make each square worth 2. Okay, so it's going to go all the way to 6, or it's going to go all the way up to here to 6 and 0. The radius is 3. The diameter, this is the diameter of the circle, is 6. So that is what it looks like. Okay. Okay. Next one is a rose curve because there's a number inside. This is the radius of the rose curve. It's going to have 3 petals. It's going to be kind of oriented sideways horizontally because of the cosine. And because it's an odd number, it's going to have that number, and we're only going to graph it from 0 to pi. So this is a rose curve. Okay, so I guess the first thing I'm going to do is sketch the circle that it's going to fit inside of, and it's going to make it easier to graph these well, which I'm going to be judging on your test, if you make it bigger. So I'm going to graph this circle first. If you don't do the circle, most likely I'm going to draw the circle and show you how your petals are too long or short in different places. So draw the circle. It's going to make it easier, make your graph look better. You want to figure out what the tips of the petals are. And so you're going to set the radius equal to the most extreme radius that we know it's going to have, which is that circle's radius 2. And we're going to solve the tree equation we get. So 3 theta equals 0 plus pi k. So theta equals 0 plus pi over 3k. So theta equals 0, pi over 3, 2 pi over 3, pi. And we only need to do 0 to pi for odd numbered petals. So let's graph those. Pi over 3 is about like that. 2 pi over 3. So in my mind, I'm always thinking I'm trying to divide this into 3 equal pieces. Okay. We also need to graph the angles in between those. So we need to graph the angles in between them because that's going to be the edges of the petals. So I don't know if I got them all. Okay, so the first one is going to be at pi over 3. That's going to be the first petal. I'm going to want you to number the petals, show me where it starts and ends, show me the direction. For a lot of these graphs, I'm going to want you to show me start, end, and direction. Okay. So, I mean, like this one, start ends at 0, 0. Direction is like this. Sorry, the previous graph. It actually starts here too. Actually, it starts here, and it starts here and ends here, and ends here. This one starts and ends here, and the direction is like that. This one starts and ends there at 0, 0, and the direction is like this. Okay, so back to this one, graphing this rose curve. So that's the first petal. Second petal is going to be at 2 pi over 3 here, but it's going to be a negative radius, so it's going to be back here. And then, so that's going to be the second petal. The third petal is going to be at, the first petal is at 0. The second petal is at pi over 3, but it's going to be negative radius, so that's going to be over here. It's going to be the second one. I messed up there. And then the next one's going to be a 2 pi over 3, it's going to be a positive radius, so that's going to be a third petal. So I made a little mistake. So first one looks like this, and then it goes like this, and they should flow very nicely from one into the next in the order that we predicted. So it starts and ends here at 2, 0, and it goes this direction, right? And then I want the petals numbered too. So I made a little bit of a mess of that. So here's another rose curve. This one has a radius of 3. The negative is just going to probably change the direction, but the radius should be a positive number. It's going to have 4 petals because it has an even number inside. So the second set of petals are actually in between the other ones. Whereas in the odd ones, we have these in between areas that just don't get anything because the second set of petals is right on top of the first set if it's odd number. So we got to figure out where the tips are. We could go ahead and graph the circle that's going to fit inside of white dashed line. It's not really part of the graph. It's going to help you make a nice graph though. Okay, so the tips are plus or minus equals -3 sine 2 theta. So that's going to be plus or minus 1 equals sine 2 theta. So 2 theta equals pi over 2 plus pi k, and theta equals pi over 4 plus pi k, pi over 2k. So theta equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, I'm looking for those angles in your picture, and I want those ones, I want them labeled. So there's the angles. So right here, theta equals pi over 4, theta equals 3 pi over 4, theta equals 5 pi over 4, and theta equals 7 pi over 4. I want those labeled on your graph, okay? Then we want to draw the angles in between them that cut them in half, which are the axes, because those are going to be the edges of the petals. And the first petal is going to be at pi over 4, and it's going to have a negative radius, so it's not going to be here, it's going to be back here. That's going to be the first petal, okay? The next petal is going to be a 3 pi over 4, it's going to be a positive rate. It usually would be negative, but because it's extra negative, it's going to make it positive, so that's the second petal. Third petal is going to be here, but it's going to have a negative radius. It's going to be back here. This is the third petal. And then this is going to be the fourth petal. And so the graph, if you plug 0 in here, you're going to get 0, 0. So it starts here at the origin. And it has a bunch of negative radiuses first. So it goes like this. It fits nicely, and it goes perfectly into the second one, and it goes nicely into the third one, and then it goes right into the fourth one, and then it starts to repeat itself. So the start end of the graph is at 0, 0, and the direction is like this. So you can draw maybe a little arrow showing the direction. And then the petals should be numbered, which also helps. I'll help you see the direction. So that's what I'm looking for. Next one is a cardioid, because these numbers are the same. As far as the limousin family, I would do a quick table. It should be sideways, horizontal looking, which my table will confirm. And so you plug 0 in there and you get 4. You plug pi over 2 in and you get 2. You plug pi and you get 0, 2, 4. So we're going to go all the way to 4 here, and then 2, and then 0, and then positive 2 down here. It's going to look like this. And I'm looking for it to look very, very round. Okay. I'm warning you, if it looks like this, I'm taking off points. Okay. So it starts and ends right here at 4, 0, and the direction is this direction. Okay. So there you go. And we have another cardioid. So it's a table. And so 0 is going to be 1, 0, 1, 2, 1. So I'm going to put 1 here, 0, pi facing over here, -1. 3 pi over 2 facing down to here, which is going to be at -2. So there you go. Something like that. It starts and ends at here. Starts and ends at 1, 0. And the direction is like this. Okay. So you're going to have 4 graphs. Probably a couple weird ones like this first one, and then a couple very common ones. You're also going to have a lot more room on your test for the next problems than you do here. So the next problems, like we said, I've given you a couple derivatives. Just find the slope of the graph, and you'll probably have like one of these on the actual test. I would say doing a quick sketch of these is helpful because it'll tell you what kind of slope you should get: vertical, horizontal, positive, negative, which could help you catch some mistakes. So, this is a circle. And like I said, you're going to have more room on test. It's going to be 303. So it's going to look like this. It's going to look like that. That's what that graph looks like. Um, let's see. I mean, if you don't do the graph, that's fine. I'll give you full credit if you get it right, but I'm just saying this might help you. So at pi over 6, that'd be like somewhere around here. So I don't know. I mean, maybe it's gonna be a negative slope. It's hard to tell, or could it be that horizontal one? I don't think it's gonna be vertical. So we'll see what happens. It looks like it'd be a negative slope. So to find the slope, thing you need to remember is dy dx equals dy d theta over dx d theta. Very similar to parametrics, or it was dy dt over dx dt. So we got to write down x equals r cosine theta. So it's going to be 3 cosine squared theta, and y equals r sine theta. So it's going to be 3 sine cosine theta, or however you want to write those. And then we're going to do dy dx equals, like I said, dy d theta over dx d theta. So we're going to probably have to do some product rules and stuff. So this one, the top, I guess we could just do 6 cosine theta and then negative sine theta, because we'll combine those together. The bottom's going to be 3 sine theta times negative sine theta plus 3 cosine theta cosine theta. And then we could plug the angle in. I don't want you to use any of those formulas, even if they might be in some of my work solutions stuff. I don't want you to do that. This is the way to go. Use the formulas. I might just take off some points anyways if you get them right. But if you get them wrong, which is the reason I don't want you to use them, because they're harder, more work, I'm going to judge harder. So cosine pi over 6 is root 3 over 2. And sine pi over 6 is 1/2. And sine pi over 6 is 1/2. And cosine of pi over 6 is root 3 over 2, and that's root 3 over 2. So let's see. Negative 3 root 3 over 2 on the top. On the bottom, it's going to be minus 3/4. That's going to be 3 plus 9/4. We could multiply top and bottom by 4. Just get rid of these fractions. So it's going to be negative 6 root 3 over 6. And final answer is going to be negative root 3. Let's see. Oh, did I make a mistake? Let's see. I might have made a mistake over here. Let's see. 3 sine. Oh, that looks right. Oh. Oh, now I did it upside down. I did X on top and Y on the bottom. Okay. I'm not going to redo all the work. I'm going to just draw these arrows. Show that. Gosh. So it should be negative 1 over root 3 or negative root 3 over 3. Oops. All right. Came out negative. Expected. All right. Okay, so next one, doing the same kind of thing. I'm gonna do a quick sketch. It's probably like a Lima song, like an interlude or something. Do a quick. All right, so plug 0 in, you get 1, 3, 1, -1, 1. So it's gonna be kind of taller. 1, 2, 3. So 0, 1, pi over 2, 3, pi 1. And then at 3 pi over 2, it's -1. So there's that inner loop. And it's going to go through the pole. Okay, so we're trying to find at pi over 6, which would probably be like somewhere in there. So maybe it's going to be vertical, or it could be positive. I don't know. It's not going to be. It's not going to be 0 or small. Okay, so x equals r cosine theta, 1 plus 2 sine theta cosine theta, y equals r sine theta, 1 plus 2 sine theta sine theta. So dy dx equals dy d theta over dx d theta. I'm going to try and not do it upside down this time, even though I feel like that happens to me every now and then. So because you just kind of instinctively go with the first one you wrote, which is x. But so 1 plus 2 sine theta cosine theta plus sine theta 2 cosine theta. Bottom's going to be 1 plus 2 sine theta negative sine theta plus cosine theta 2 cosine theta. And so then we're going to plug pi over 6 in. And let's see, we're going to get 1 plus 2 times sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. Cosine of pi over 6 is root 3 over 2. 1 plus 2 times sine of pi over 6 is 1/2. Sine of pi over 6 is 1/2, but there's a negative already there. Root 3 over 2. 2 times root 3 over 2. Okay, just be careful. All right, let's see if we can clean this up. That's going to be a 1. That's going to be a 2. That's going to be a root 3. And that's going to be a root 3 over 2. And that's going to be 1, 2. That's going to be -1 plus 3 over 2. So we can multiply the top and bottom by 2. And we get 2 root 3 plus root 3 over -2 plus 3 gives you 3 root 3 over 1. So it's going to be 3 root 3. There you go. 3 root 3. So it's definitely, it's positive. It's pretty steep. So I guess it's a little more over here to be positive. Okay, now we're looking specifically for vertical tangents and then horizontal tangents. So you might get one like this on the test, and just watch out because sometimes it might come up on both of them. It's only going to be a certain one of them. So you could do L'Hopital's rule, or I'm going to be cool with you just drawing a picture, which drawing a picture should be easy and it will make the answer obvious. Now, if you have no evidence of a picture, you have no L'Hopital's rule, you have no checking the other vertical horizontal, I'm taking off points because I'm just assuming you got lucky. So vertical tangent is going to be when dy dx equals undefined, which means that dx d theta equals 0. Now this is a cardioid, so I'm going to do a quick sketch. And this is going to show me where where they're going to show up, how many, and it will help solve any kind of ambiguous cases. Plug 0 in, 2, 1, 0, 1, 2. So this is a cardioid, bigger in the x direction. So horizontally oriented 0, 2, pi over 2, 1, pi 0. It's the cusp that causes the problems. It's going to come up as 0 for both of these. For dy d theta and dx d theta, it's going to come up 0 both, but it isn't both. Now we're looking for vertical tangents. So we see one there, one here, one here. So we should get one here, we should get one here, we should get one here. So it shows you how many you're going to get and about where they are. So we need x equals r cosine theta. So that's going to be 1 plus cosine theta. And so then we want to do dx d theta. And so that's going to be 1 plus cosine theta times negative sine theta plus cosine theta times negative sine theta. And we're going to set that equals 0. So I think we factor negative sine theta out. And there's going to be 1 plus 2 cosine theta left inside equals 0. So sine theta equals 0. And cosine theta equals negative 1/2. So theta equals 0 plus pi k. So theta equals 0 pi 2 pi. And we're looking for all the answers from 0 to 2 pi. So even if it happens at multiple places or at the same place at different angles, then we need to list them all. This is going to be reference angle of pi over 3. Quadrants 2 and 3 are where it's negative. So theta equals 2 pi over 3 plus pi k, or plus 2 pi k. And theta equals 4 pi over 3 plus 2 pi k. So we get theta equals 2 pi over 3 and 4 pi over 3. Now, that looks like the 2 pi over 3. That looks like the 4 pi over 3. That looks like the 0 and the 2 pi. This one should not be in the answer. Now, I should see it come up in your work, but then you're going to decide. You say it's a cusp. It's horizontal based off the picture. You have a little picture. Otherwise, feel free to do L'Hopital's rule. It's not fun. And that's just to try and get full credit, even if you know that it's not vertical. It would come up as horizontal, come up as 0 for both of these. Okay, next one, look for horizontal. This is a cardioid. So, quick sketch. This is going to be vertical in nature. So if we plug 0 in, I'm getting 2, 0, 2, 4, 2. So it's going to be bigger in the down direction. Okay, so there's the shape. All right, let's see. So horizontal tangent is going to be when dy dx equals 0. So that's going to be when dy d theta equals 0. And so y equals r sine theta. So that's going to be 2 minus 2 sine theta. And so then we're going to do dy d theta. It's going to be 2 minus 2 sine theta, cosine theta, plus sine theta, negative 2 cosine theta. And that's going to equal 0. And then I think we could factor out the cosine out of both of them. So we take cosine theta out. There would be a 2 minus 2 sine theta, and then another minus 2 sine theta. So 2 minus 4 sine theta equals 0. So cosine theta equals 0, and sine theta equals positive 1/2. Now, by the way, answers we expect to get horizontal tangents to be here, here, and here. So I expect to get 3, one in the first quadrant, one in the second quadrant, and one down here at 3 pi over 2. So theta equals pi over 2 plus pi k. Theta equals pi over 2 and 3 pi over 2. And reference angle here is pi over 6, quadrants 1 and 2. So theta equals pi over 6 plus 2 pi k. And theta equals 5 pi over 6 plus 2 pi k. And so we're going to get pi over 6 and 5 pi over 6. Now, this is the one I think we need to throw out because that's where you get in the cusp. And you could say, cusp, it's going to be vertical based off graph. So one, you better identify that's not an answer. It should show up in your work, but then eliminate it. 2, you got to give me a reason to support it. You could graph it, talk about the graph, right? Or you could do L'Hopital's rule and show me that way. I think maybe in my work online, if you check these, I have the L'Hopital's rule version, but I don't think anyone's going to really want to do that. So there you go. You guys can have one problem like that. And then finding the tangent lines to the curve, and a problem like that. So that involves finding dy dx like we just did, but then also finding the point and writing the equation. Now, again, I think drawing a sketch of this would be helpful. So this is some kind of limacon. If we did a quick table, if you plug 0 in, you're going to get 2 minus root 3. Plug pi over 2 in, you're going to get negative root 3. Plug pi in, you get negative 2 minus root 3. Plug 3 pi over 2 in, you're going to get negative root 3. And plug 2 pi, you're going to get 2 minus root 3. Okay, so this is kind of ugly. Square root of 3 is about like 1.7. So this would be about 0.3. This would be about negative 1.7. This would be about negative 3.7. This would be about negative 1.7. And this would be about 0.3. So quick sketch. I think this graph is going to be bigger in the right direction. So it says at the pole, by the way. So we're looking at the pole. There might be multiple tangent lines at the pole, but we're going to be able to use a shortcut if we want for dy dx here. So let's just try and sketch this. 1, 2, 3, 4. So the first point's right here, and then pi over 2 is going to be down here, negative 1.7, and then pi is going to be negative 3.7, so it ends up in here backwards, and 3 pi over 2 going backwards up here. So you're getting the limacon with a little tiny inner loop. Okay, and so we're trying to find the equations, the tangent lines at the pole. which it looks like we get two of them. They're probably going to have the same slopes. One's positive, one's negative. Not perpendicular. Not negative reciprocals, just negatives of each other. We got to figure out where it goes through the pole. We suspect it does between 0 and pi over 2 and pi over 2 and pi. So probably first quadrant, second quadrant. And so we're going to set the equation equal to 0 and solve for the trig equation. So we need positive root 3 over 2. So alpha equals pi over 6. And we're in quadrants 1 and 4. So theta equals pi over 6 and 11 pi over 6. So we go in, start here, we go in, go through here, and then we go all the way around. Then we come back in right before we're done with it. So that kind of makes sense. Okay, so we already have the x and y values. So we already know it's 0, 0, so that helps. But we do need to do x equals r. Well, we could probably even skip this. We can use the shortcut. I'll write it down. But this is where that shortcut's going to really pay off. So the slope at the pole, we said for dy dx always ends up being tangent theta, sine over cosine. That's way quick, way easy. You can skip all this work. We already know it's a 0, 0, so we don't need the x, y equations for that reason either. So dy dx at theta equals 11 pi over 6. Sine pi over 6 is 1/2. Cosine pi over 6 is root 3 over 2. It's going to be 1 over root 3. It's going to be root 3 over 3. So that's the slope of that one. The other one, I guess we could write the equation of this one. Y minus 0 equals root 3 over 3 x minus 0. Point slope form. Or if you want, you could write y equals root 3 over 3x. It's pretty easy this time. So the other one, dy dx, theta equals 11 pi over 6. It's fourth quadrant, so you can get negative 1/2 for that and positive root 3 over 2 for that. It's going to be negative 1 over root 3. It's going to be negative root 3 over 3. So the equation is going to be y minus 0 equals negative root 3 over 3 x minus 0. Or y equals negative root 3 over 3 x. So there you go. Tangent lines at the pole. Okay. Now the one on the test might not be at the pole, but okay. So I don't know what this is going to look like. Let's do a quick sketch. 0 pi over 2 pi 3 pi over 2 2 pi. Plug 0 in here and get 1. Plug pi over 2 in. It's going to be cosine pi over 2. It's going to be negative 3. Oh, this kind of looks like some kind of potential rose curve or something. I don't know. Plug pi in, you get 1. Plug 3 pi over 2 in, you get a cosine of 3 pi is, that's going to be negative 3, and it's going to be back to 1. This kind of seems like it might have some kind of like 4 petals involved with it. When you go to graph this, I mean, I don't think, I'm not going to use something like this on the test, but 0, 1's here. Pi over 2 is down here. Pi is here. 3 pi over 2 is up here. So what happens is, and then you can figure out, well, does it go through the pole? Well, you probably should figure out when it goes through the pole anyways, the angles, right? So you got to figure out when it goes through the pole. So r2 cosine 2 theta minus 1 equals 0. So cosine 2 theta equals 1/2. So reference angle is pi over 3, quadrants 1 and 4. So 2 theta equals quadrant 1. That's going to be pi over 3 plus 2 pi k. So theta equals pi over 6 plus pi k. And It's going to be 5 pi over 3 plus 2 pi k. Theta equals 5 pi over 6 plus pi k. So we're going to have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So it looks like potentially 4 places where it goes through the pole. Now, where are those here? Pi over 6 is between those, that and that, 5 pi over 6. So in between these points, it's going through the pole every time. So it started here, and what it does is it goes through the pole, and then it goes down to here. Then it goes back to the pole, and it goes to there. And then it goes back to the pole, and it goes up to here. And then it finishes and goes like that. So it kind of looks like a, 4-petal rose curve, but this -1 here is kind of stretching it, I guess. So tangent lines there and there, I'd say there's really only 2 tangent lines, even though it goes through the pole. These guys are tangent to each other also. So I think we're just going to get 2 answers. But we're going to go ahead and use, dy dx equals tangent theta at the pole. So dy dx for theta equals pi over 6 is going to be, sine pi over 6 is 1/2 over root 3 over 2. It's going to be 1 over root 3. It's going to give you root 3 over 3. And we do dy dx equals theta equals 5 pi over 6. That's going to be 1/2 over negative root 3 over 2 because it's second quadrant. So that's another one. And then I think we're going to get the same values if we plug these other ones in. 7 pi over 6. It's going to be negative 1/2 over negative root 3 over 2. So it's going to be positive 1 over root 3. So it's going to be positive root 3 over 3. And then 11 pi over 6, that's going to be negative 1/2 over positive root 3 over 2. So that's going to be negative 1 over root 3. So that's going to be negative root 3 over 3. So we could say y minus 0 equals root 3 over 3, x minus 0. Or you could say y equals root 3 over 3x. And then the other one, it's going to be y minus 0 equals negative root 3 over 3, x minus 0. So there we go. All right. Let's keep going. You can do it. You can do it. Find the area inside this shape. This is a cardioid. You could draw a picture to try and take advantage of symmetry and things like that if you want. Or you could probably just do it without a picture. Understand that you're going to go 0 to pi. It's going to be 2, 1, 0, 1, 2. So I don't really know if you could probably get away without drawing a graph here. The ones that involve multiple curves, you for sure need a graph. But okay, so you could do that. You could do the whole thing, or you could do half of it, double it. So the whole thing would be 1/2 0 to 2 pi 1 plus cosine theta squared. So you could do that, or you could do symmetry and say, well, let's just do half of it 0 to pi, and then double it. Okay, the work's going to be very similar. So it's up to you. I'm just going to go and finish this one right here. So it's going to be 0 to pi. You got to multiply that out, full it out. And then we can't integrate this, so we're going to replace it with 1/2 plus 1/2 cosine double angle. So then the antiderivative is going to be 1 and 1/2. That's a 3/2 theta plus 2 sine theta plus 1/4 sine 2 theta. So 0 to pi. It's going to be 3 halves pi plus 2 times sine of pi is 0. Sine of 2 pi is 0. Plug 0 in. Sine of 0 is 0. Sine of 0 is 0. So lots of things drop out, and we get 3 pi over 2. Okay. If you look at my work, I have online, I have the work for the other one. Okay. Next one, find the area of this. This is a rose curve with 3 petals. Like I said, I don't think using symmetry is going to help. It's going to be too hard to figure out. I would say let's just find the whole thing. Let's not even sketch it. I mean, you could if you want, but 0 to pi. Now, here's the key. It's 0 to pi, not 2 pi, because it's the odd number of petals. If it's an even number, you go 0 to 2 pi. So now it's going to be minus 1/2 of doubling of cosine. It's going to be 6 theta. It's got to be cosine. It's got to be negative. Okay, so minus 1/12. Put pi in. Cosine 6 pi is 0. Plug 0 in. Sine of 0 is 0. So we get the answer, pi over 4. I mean, that's the way I would do it. Or you could graph it and try and find a single petal and then multiply by 3. If I wanted a single petal, I'd find the whole thing, divide by 3. Okay. Okay, you find the area between multiple curves. These ones, pictures are huge. Big deal. So this is a circle, and this is a cardioid. So we definitely want a picture of these. So the circle, and then the cardioid. Okay, that's going to be 1, 2, 1, 0, 1. So both of these are kind of big in the vertical direction. So 0, 0, 5, 2, 3. So we got a circle. And then you got 0, 1, 5, 2, 2. That's a cardioid. Okay, we're trying to find the area that's inside both of them. So that's going to be all this. So the way we're going to find this is we're going to find the intersections, because these angles are going to be a big deal. Okay, and what we're going to do is we're going to find this area first from the circle, and then we're going to find this area from the cardioid, and I would then just double them. But you gotta break it up along that angle that cuts those in half, and then it depends on the edge of that region, which curve creates it. That's the one you're going to integrate. So this one is just a little bit of the circle, and then this one's of the cardioid. So we got to figure out where they intersect each other. Expect first quadrant and second quadrant. So reference angle is pi over 6, quadrants 1 and 2 like we expected. So theta equals pi over 6 and 5 pi over 6. So I'd label those on your picture. Now, what I'm going to do is I'm probably just going to do half of it, do pi over 6, to pi over 2, whatever. So my strategy here is we're adding two areas up, right? We're adding two areas up. So we're going to do 1/2. We're going to double it. We're going to do that one, 0 to pi over 6. And that's of the circle. That one's the 3 sine theta squared. And then we're going to do the other one, starting at pi over 6, going to pi over 2. And that's the cardioid. So that's the setup. That's the setup I would do. Or you could go, yeah, I don't know. That seems like by far the best idea. Use symmetry. Okay, so we're going to get 9, 0 to pi over 6. And we're going to change it to 1/2 minus 1/2 cosine double angle. And this one's going to be 1 plus 2 sine theta plus sine squared theta d theta. Need parentheses around all that stuff. This is going to be 1/2 minus 1/2 cosine double angle. Right? Okay. So now I'm going to integrate antiderivatives. Three halves theta minus 2 cosine theta minus 1/4 sine 2 theta. So I think that's it. Just be careful here. Show your work. Easy. Yeah, I mean, if you make it's easy to make some little mistake. I got to be able to follow your work. I got to be able to see things. So sine of pi over 3 is root 3 over 2. Okay. Pi over 2, that's going to be 3 pi. Cosine of pi over 2 is 0. Sine of pi is 0. And then that's going to be 3 pi over 12. Cosine of pi over 6 is root 3 over 2. Sine of pi over 3 is root 3 over 2. Okay, let's see. Can we clean this up? 3 pi over 4 minus root 3 over 8 plus 3 pi minus pi over 4 plus root 3 plus root 3 over 8. So when I combine these together, give them probably some least common denominators and stuff. I mean, we could make this over 4 like the other pi term. So that would be 12 plus there's 15 minus 1 is 14 pi over 4. And then these guys cancel each other out. So we get plus root 3. So 7 pi over 12 plus root 3. That's what I'm getting right here, which is not what I got in my work. So I'm not really sure what I messed up. Oh, this should have been 3 pi over 4, right? So it was already a 3 pi over 4. So that'd be 6 pi over 4 minus 1 pi over 4. It'd be 5 pi over 4. So that's one mistake right there. And then Let's see if we can find the other mistake, or if there is another mistake. Oh, this 9 gets distributed to this, so this should be a 9. So we have negative 8 root 3 over 8, which would be negative root 3. So, I mean, we could give this guy least common denominator. So it's 8 minus 9 is negative 1 plus 1. You have those go away. So I made a couple mistakes there. It's hard. It's going too fast, but it's part of it. Got to do well under pressure. Okay, last one, arc length. So the arc length formula, which you might go ahead and write down, is the integral of the square root of r squared plus r prime squared d theta. That's what we finally developed. So for us, that's going to be 0 to pi, and we're going to plug in e to the 2 theta squared, and the derivative of that, r prime equals 2e to the 2 theta, right? So that's going to be 2e to the 2 theta squared. And let's see if we can actually solve this without a calculator. I think we might be able to. So it's going to be e to the 4 theta plus 4e to the 4 theta. And then that's going to be 5e to the 4 theta. And then that's going to be, we take square root of 5 out. And the square root of e to the 4 theta is going to be e to the 2 theta. So square root goes away. So then when you integrate it, it's going to be e to the 2 theta, but an extra 2 is going to pop out. So we need a 1/2 to counter the chain rule. So we get root 5, 1/2 e to the 2 pi minus 1/2 e to the 0, which is 1. So it's going to be root 5 over 2 e to the 2 pi minus root 5 over 2. So that, or that, or, I mean, whatever, there's a bunch of different ways you could write it. That, one of those. So, okay, just under an hour. All right.